Okay, in this video we're going to be looking at sketching reciprocal functions. And what reciprocal, remember, means is 1 over something. Okay, so what we're going to be looking at is sketching y equals 1 over something down here. And I just write something, just write fx, some function of x under there. Okay, and so what that might look might be 1 over 2x plus 1, or it might be something like y equals 1 over x squared plus 3x, or something like that. 1 over the function, so that's what we mean by reciprocal functions. It's quite simple when you know how, but it's something that might be really hard to think about what that actually looks like, 1 over a quadratic or something like that. Now in this course, the f of x here, that'll never be, it'll only ever be degree 1 or 2. Okay, so linear or quadratic. It'll never be a cubic or anything like that. So all you need to worry about is linear ones and quadratic ones. That's all we need to look at. Okay, so I'll go through it more specifically in class, but I just want to show you, just go through an example or two to show you what we're talking about. In fact, yeah, let's just do it. Example. Okay, to sketch, let's have a look at y equals 1 over x squared plus 4x plus 6. Okay. Alright, let's have a go. Let's have a go at sketching this. Now, what we want to do first, the first tip is to sketch the actual quadratic or whatever's on the bottom line. And then once we know what that looks like, we can take the reciprocal of each point. Okay, so I should have got my graph, but I'm just going to sort of do one down here. Started out looking pretty good. And there. That's not a bad axis. So I've got that. So what we actually want to look at is, firstly, let's look at y equals x squared plus 4x plus 6. What does that look like? Plus 6. Okay, if we were to sketch that, let's complete the square. So that's x squared plus 4x plus 4 minus 4 plus 6, which is, I'm just going to go straight across, sorry, x plus 2 squared minus 4 plus 6 plus 2. Okay, so what that looks like is a parabola. It'll be negative 2, 2, so there'll be some point here at 2 and negative 2. That'll be its turning point. I'm not going to worry about being accurate or anything like that, but what I'm just going to do is draw it in a dotted line. Okay, so I'll just draw a parabola. Okay, something like that. That's what the bottom line is going to look at. I'll just slip down a bit here. So that's the parabola, what the bottom line looks like. Now what we want to do to be able to sketch our function is we want to look at the original function and just take the reciprocal of all the y values here, all the function values. In other words, just have a think about it. So let's start right in the middle here. We've got y is equal to 2 here. If you've got the reciprocal of that, that's 1 over 2. So 1 over 2 will be down here, which is half. So that's our value there. Okay. Let's have a look as it goes up here. We'll go to the left here. As this gets bigger and bigger and bigger in this direction, what happens to its reciprocal? So in other words, it's equal to 2 there, but it's equal to, say, 3 there. That would be equal to 1/3. So it's a bit smaller there. Okay. What happens over here? It's equal to, sorry, I said negative. Y in here would be, let's say, 4 or 5. That would be 1/4 or 1/5. Okay. In other words, as this gets bigger and bigger and bigger in this direction, its reciprocal gets smaller and smaller. In fact, it gets closer and closer and closer. Sorry, my drawing is really bad. It's really bad. You're not going to forgive me for that, are you? It makes it like a little bell shape and it goes down and closer. That's pretty good. It gets closer and closer. Let's have a look in the other direction. What happens in the other direction? Well, again, as this gets bigger and bigger and bigger, its reciprocal gets smaller and smaller and smaller. So in fact, it goes down. I'll do it again. Yeah, that's really bad. It should be symmetrical. I'm going to leave that, it's not very good. But in general, it'll be like a bell shape like that, goes up and down like a curve, okay? And that's an asymptote there. Y equals 0 is an asymptote there. And so that's what it looks like basically. It never reaches the x-axis. It just goes up and down in a bell shape. And in general, if you have a quadratic that looks like this, then your reciprocal will look like that. And it just depends on what, it won't be the same turning point necessarily, but you just need to find out. But wherever the x value of the turning point of your quadratic is, will be the same x value turning point for the reciprocal, so it will look like that. If you have the other instance where it was like this, do a better one than that. Like something like this, say, that's your quadratic. The reciprocal will be in the other way, so it will come there, go up, and back down like that. That's what the reciprocal will look like in that case. Okay, so that's what happens. Now, you'll notice that I've chosen quadratics that don't cross the line here. In other words, don't cross the x-axis. So in these ones, they don't cross the x-axis. In other words, your discriminant, well, not equal to, your discriminant in this case will be less than 0. So if your discriminant for your bottom line is less than 0, you'll get this sort of thing where you just get a lump or a bell-shaped curve, that sort of thing. So that's that. Let's do another example where the actual parabola will cross the x-axis, and we'll see what this looks like. This is a bit more interesting in that case. So let's do another one. Let's sketch this guy. Y equals 1 over 6. That doesn't look like a 6. 6x minus 8 minus x squared. Okay, cool. Let's sketch this guy. Again, let's look at what the bottom line looks like, and then we'll go from there. Okay, so if we look at y equals, I'm just going to rewrite it with x squared in front, so negative x squared plus 6x minus 8. And I want to know what this looks like. I'm going to complete the square. So negative x squared minus 6x. I want to complete the square here. I need to add 9. I'm going to close the bracket there. What I've done is minus 9 here, because that's a negative out the front. I've actually effectively subtracted 9. So I need to add 9 minus 8 equals x minus 3 squared. Oops, negative out the front. Negative x minus 3 squared plus 9 minus 8 plus 1. Okay, fantastic. I'll just go straight to a big sketch. Okay, straight to a big sketch. Nice and big. So let's see what's going on. Right, let's just quickly sketch this parabola. I'll do it in like a green or something like that. I'm doing the proper one in red. What is this? It's a maximum graph at x equals 3 and positive 1. 3 and 1 is our maximum turning point, so it looks something like that. You could go and find out what those x-intercepts are. I'm not going to bother, I'm not going to have time, but if you're asked to, in fact no, you should figure that out. Do so. So it'll look something like, it'll come up, go down like that. Okay, so there is your parabola. Now that's not the graph of what we've been asked to sketch. So I should have done it in a dotted line. In fact, I will, just to, don't want to confuse anyone. Oh, it was starting so well. Not too bad. There is our parabola of the bottom line. What we need to do now is figure out what the reciprocal of this looks like. In other words, for all these y values, what does 1 over all those y values look like? Okay, so for each point. So I'll get my red pen out. I'll change pens to have a look at this. Now, let's start with the turning point. Here, y is equal to 1. What is 1 over 1? Well, it's actually 1. So that is actually part of our new graph as well. And in fact, whenever y is equal to 1 or negative 1, whenever your turning point is at y is equal to 1, it'll be the same. That's the only time it'll be the same. Okay, so there we go. Explain those things in class. Now, let's just have a look at a couple of other points. How about here? What is y equal to here? Y is equal to 0 at this point right here where it goes through the x-axis. So what's 1 divided by 0? It's undefined. And so what happens when it passes through there is you're going to get an asymptote. Okay, so we'll get an asymptote there, and it'll be the same for here. Y is equal to 0 at these points, and so we'll get asymptotes. The function will be undefined at those points. Right, now let's have a look. Let's start with this center section. What happens in here? The function here is getting smaller and smaller and smaller. What happens to the reciprocal function as the quadratic gets smaller and smaller? It's going to get bigger and bigger, so it's going to go in the opposite direction. As this gets closer and closer and closer to 0, this is going to get closer and closer and closer to infinity. And so what it ends up is looking like this. It gets bigger and bigger and goes to infinity as an asymptote. And so it approaches this asymptote here. Same thing happens on this side. Here the function is getting smaller and smaller and smaller, and so this function gets bigger and bigger and bigger. And so in general, if the bottom line gets smaller and smaller, then the whole thing gets bigger and bigger, because it's 1 divided by a very small number, which is a very big number. Okay, so that's the center section. That's nice, isn't it? Let's have a look what happens out here in its extremities. At this point right here, it's a very, very small but negative number. Actually, I'll do it over here because I did it a bit messy there. Here, it's a very, very small negative number. So what's 1 divided by a very, very small negative number? It's a very, very large negative number. So in actual fact, it's going to be out here somewhere. Down here, it's going to be very, very large. As this gets bigger and bigger and bigger, what's going to happen to this? It's going to get smaller and smaller and smaller. So as this goes to infinity, it becomes massive negative number. This will become a very small negative number. So in actual fact, it ends up looking like, oh, doesn't cross. Start that again. It's quite hard with this tablet that I use. Yes, and it's going to be an asymptote going closer and closer like that as well. Okay, and the same thing will happen here. As that is a very small negative number, this is going to be a very big negative number, and it's going to be similar to that, looking like that as an asymptote at y equals 0. Okay, and that's what those look like, and they always look like that. So anytime you have any quadratic, if you've got a quadratic that looks like that, the reciprocal of that will be always get asymptotes there, and it will look like that, that, and that, whatever. Okay, and the reciprocal will always look like that. So that's something to get used to. It'll either be the bell-shaped curve from the previous example, or it will look like this, where it's got the 3 sections to it with 2 asymptotes. Very good. If the question asks you to, well, no, you should always write down what those asymptotes are. And so I haven't figured them out here, but you will, because you're good, but I just haven't got enough time. Asymptotes, intercepts, those sort of things are always very important. Of course. See you in the next video.